Chapter 8.3 is more properties with exponents. Now, in Chapter 8.2, you guys learned the first law of exponents, which is that when you have the same base with different exponents and you're multiplying them, then you simply add the exponents. So the x is the base, and then you're adding the two different exponents, a plus b. In real life, it looks like this. If you had x to the 5th times x to the 7th, then it would be x to the 5 plus 7, or x to the 12th. Using numbers, it would be 5 cubed times 5 to the 4th, and that would equal 5 to the 3 plus 4, or 5 to the 7th. And you might be able to leave it in that form if your teacher's nice. In Chapter 3, you're going to learn two more laws of exponents. The first one that you're learning is called the second law of exponents, a very creative name for it. And that is that if a and b and a minus b are equal to positive integers and x is any number other than 0, then this rule applies, and that's x to the a divided by x to the b equals x to the a minus b. In words, this is simply that to divide powers of the same base, we subtract the exponents. If you saw this in variables, you would have x to the 7th divided by x to the 5th, which would equal to x to the 7 minus 5, or x squared. In numbers, you could have 5 to the 4th divided by 5 cubed, which would be 5 to the 4 minus 3, which is 5 to the 1, or simply 5. You can also do this with scientific notation. If you had 3 times 10 to the 10th divided by 40, you might want to rewrite it so that you have 3 times 10 to the 10th divided by 4 times 10 to the 1. Okay, then you're going to take these numbers and divide them. Okay, so 3 divided by 4 is 0.75 for all of you who are really good with decimals. Okay, and then you have 10 to the 10th minus 1 would be 10 to the 9th. Now this is not proper scientific notation form, so we would need to move the decimal to the right. So we're making this small number bigger, and that means in order to keep it equivalent to 0.75 times 10 to the 9th, we're going to make the 10 to the 9th smaller. So it's going to become 7.5 times 10 to the 8th. I should have given you this example first, because this one's a little bit easier. You just do the 9 divided by the 3, which gives you 3. Okay, then you're going to do 10 to the 9th divided by 10 cubed, or 10 to the 9 minus 6, and I could write that. 9 is minus 3, excuse me, which would be 3 times 10 to the 6th. And because this is in proper scientific notation form, you're done at that point. Now the third law that you also learn about in 8.3 is this one, raising a power to a power. Okay, and that is if a and b are positive integers, then x to the a raised to the b equals x to the a times b. Okay, in words, this is that to raise a power to a power, we multiply the exponents. If you had x cubed, for instance, raised to the 4th power, it equals x to the 12th, because 3 times 4 equals 12. You could also write it this way, x cubed times x cubed times x cubed times x cubed, because it means x cubed multiplied by itself 4 times. And then you can simply revert back to law 1 if you'd like, and just simply add the exponents. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, and you end up with x to the 12th. Hopefully, you find this one a little easier to do. Sorry, and one more problem. If we had it with numbers, 5 cubed raised to the 4th, it would be 5 to the 12th. And again, you could write 5 cubed times 5 cubed times 5 cubed times 5 cubed. But since math is pretty much all about efficiency, if we just learn law 3, we can skip right down to 5 to the 12th.